Welcome back everyone to another Unreal Engine 4 tutorial, and today let's add some windows to our build. So in this tutorial, first we are going to create the functionality to make these windows fit in their places, and then at the end of the video we are going to create a material for the glass so that I wouldn't bother you if you already know how to create glass. So let's get right into it. So let's go to our third-person character and let's add a new function, and I'm gonna call this build window preview. So just like in the other events functions, I'm gonna select the floor and I'm gonna copy the top part again. Let's paste this in, connect this, promote to local variables. There we go. And from here we are going to do a if branch check. And what we want to check is our build rotation, and we want to see if this is equal to 0. So basically, is there a rotation or is there not a rotation? Then on the true, let's work on this. Let's drag in our local X, because if there is no rotation, that means that we want to build windows in the X-axis. And we need to do again a division. Call and reminder, division is 100, since my windows are 100 units wide. Then I want to bring in our step loop, connect into the true, return value into the last index, and from here again the index value needs to be multiplied integer times integer, and one of these is going to be 100 and the other one is going to be a -100. Then we want to check if our X is positive, so is X positive. And then we want to set our move X, so true, and move X false. So the true one is this positive one, and then the negative one. So up until this point, this is very similar to what we've done previously, but from here what I want to do is I want to do a line trace by channel. Line trace by channel. Since my windows are exactly the same size as the logs are, but I don't want them to be always like this. Sometimes I want them to be higher or smaller, not wider like I just made them, but I want them to be higher or lower depending on how much space there is, and I want this to happen automatically so that it would stretch out depending on the free spot. So to achieve this, we need a line trace by channel. We need to check what is the distance. So here what we want to do is do a plus vector plus vector in both cases, since we are going to shoot the line. Well, we are going to get the location from our build location 1, and this is the log piece that's going to be under the window, but we don't want this 0 point for this is under the log technically, but we don't want to shoot through this log. So for this vector plus vector on the bottom, we're going to add 51. Since the log is 50, we need one more. And for the bottom one, this is, well, the limit how high we want to go, and I will make this 499. For the trace channel, I'm going to select our construct trace. Then I'm going to split our build location. I will drag in our move X. And then here we want to make a vector, and we can connect this to both of these like so. Whoops, let's go to the top one, 499. And then on this one we want to do move X plus float, move X plus build X like so. And now we can connect our X, Y, Z values like so. Now we want to do another if branch check at the end to see if we hit something. And in both cases we want to get our build instance and we want to add instance to world space in both cases. Split the transforms, so false and true. Now let's drag in our build location 1 to know where our log is. Let's split this. Let's again drag in our move x. Let's make a vector for the location, and just like previously, move x is plus float x plus x. So x, y, z, and this location goes for the both of them. And also we need our build rotation, like so, just in case if we have one, to make sure that it aligns perfectly with the wall. And for our z-axis we want to do a plus 50, since this build location is the location of the log, and we want to add our log, add our window on top of the log, so we need plus 50. And now for the top piece we need to change the scaling for the z-axis, so I will move this up a little more, split this vector, and now I want to break our out hit result because we want to get a distance. How long is the line, how much free space we have. So this one we want to divide by 50, since my windows are 50 wide, so that's the measurement we need to use in this case. Then we want to truncate this. This basically turns integer into a float, the other way around, float into the integer, so you can read it what exactly it does in the white box. And then we want to add plus 1 because here we are shooting it from 51, so if we have one free space this will return 49, and this will then in that case return 0. So we need plus 1 for every single one of the cases we will get, because it's gonna return 1 less than actually we need. And then this value can go into our z-scale, like so. So now if we would test this out, actually before that we need to loop this. So from the both ends we can go to the next step on our loop, so that this would basically create windows for the whole row rather than just one window. So guys, I found a small bug with the demolition system. On the keyboard X key, when we are turning this off, what we want to do also is reset our build location 1, because otherwise this thing will get stuck in the basically in the last location, because it is getting set from our collision over here. So we want to reset that. So now let's press play. Let's create a floor, create a wall. Let's remove a couple of blocks. Let's select a window, and boom, here we have our windows. As you can see, they are fitting in nicely. And there we go. So now let's create the other wall, the windows for the other wall, because as of right now you will see that this thing will not work at all. It simply disappears, because if the rotation is different for the log, we have no code over there. So now in our build window preview, let's copy this whole bunch. Let's connect our false over here. And this is going to be very simple. We need to change this local X to local Y. Move X to move Y. And this move X also needs to be move Y, but instead of adding X, we need Y, like so. So the X goes directly from build location, and then we are adding move Y plus build Y. This goes over here. And also this one goes over there as well. I have not connected this, so make sure you do connect these. And let's see, here also we need a move Y, and the Y plus Y goes here, and the X can go directly like so. And I believe that's everything. Let's press play. Let's build a floor, a wall this direction, a wall in this direction. Let's remove a couple of blocks like so. Now let's select a window. Boom, windows over there. Boom, windows over here. There we go. So we have our windows, and they are deciding how tall basically they need to be on their own, and we don't have to interfere with anything. And as long as there is a free space, it will scale up as much as it needs to. So now, like I promised, let's create a glass material for our window. I'm gonna go to the materials folder. I'm gonna add a new material, and I'm gonna call this glass mat. And over here I want to select my base node, make sure that the blend mode is set to be translucent, and if we scroll down a bit here under the lighting mode, this needs to be surface translucency volume. There we go. So this unlocks our metallic specular roughness. And for the base color, let's see, let's add a constant 3 vector. I'm gonna make this, let's make this white for now. I will convert this to parameter, and I'm gonna call this base color so that we can edit this in the material instance. Then for the metallic specular and roughness, I'm gonna hold keyboard key 1, and I'm gonna create 3 constants. I'm gonna connect these like so, and I will convert these to parameters. So metallic, then the other one is specular, and the roughness, the default values I'm gonna place to be 0.1. For the specular is going to be 1, and for the roughness I'm going to make this 0.1. Then I want to add 2 lerps, so I'm going to call L and click twice. So one of these goes into the opacity, the other one goes in the refraction. And now we need a thing called Fresnel or Fresnel. I don't know how to spell this correctly. I know some people say that you're not supposed to say the S letter. I don't know. But we need this thing, Fresnel. So basically this thing from the Unreal Engine website, Fresnel is the term that used to describe how the light you see reflects at different intensities based off the angle you are viewing it from. So if you look directly at the object, you can see through this, but if you are looking from an angle, you don't see through this, you see a reflection. So this thing needs to be connected to the alphas for both lerps, and we need a few more constants for both lerps. So let's create 4 more. This is the A, this is the B, this is the A, and this is the B. And I will promote these to parameters. So this is going to be the opacity lerp A and the opacity lerp B. And these ones, we actually don't really need to convert these to parameters. There is not that big of a difference once we edit these. So I'm just gonna type in 1.05 on this and 0.95. You can convert these to parameters as well if you want to try to play with these, but I didn't really see much of a difference if we change the values. The biggest thing is what comes out of this Fresnel in the alpha, and that's the major key in the refraction effect. And then I want to add another constant from the exponent in, and I'm gonna call this, let's call this opacity power, because this is basically what it kind of will do. And I'm gonna type this to be 1.5. And for these opacity lerps, let's make this 0.004 up until, let's say, 0.9. I think should be good. So now let's save this material and let's create an instance from this, and let's try to edit some values, and I'm gonna show what exactly these things do. So let's right click on our material, create material instance. Let's pop this open. And so basically if we check these, then we can edit them. The first thing, base color, I think this there is no questions. If we move this around, we can change the color of the glass. So I'm gonna make this a little, let's make this a little purple bluish. And for the metallic, as you can see, if we go higher, so this works 0 till 1 basically. The higher you go, the cleaner the glass gets, the less value there is, basically the more blurry the glass is. For the lerps A and B, so basically the A part changes the blurriness of the middle part of our material. So the higher we go, the blurrier the middle gets. The lower we go, the cleaner basically the middle part is. And for the B is the same thing, but only for the outer edges. So the lower we get, as you can see, the outer edges are starting to disappear until they are gone completely, and the higher we go, the basically darker the outer edges get. And the opacity power, of course, it works throughout the whole material. The more we have, the more transparent it is. The lower we go, the more, well, untransparent it is. The roughness does what roughness does. The higher we go, the less shiny it is. The lower we go, the more shiny it gets. And the last parameter, specular, it basically changes how much light gets reflected from the material. So if you go at 1, it will reflect a lot. If you go at 0, it's not really going to reflect that much. So that's basically it for the glass material. So now what I will do is go to my window mesh, and I will add the glass material instance to this. And as you can see, if we look from an angle, it's a bit blurry. If we look directly, it's very nice and clean, just like, well, the windows should be. Yeah, like always, I forget to change the material. This needs to be used in the static instant static mesh. Otherwise, this never works with instances. So as you can see, our windows are looking pretty cool, and everything is working nicely. So thank you guys for watching, stay tuned, and see you guys in the next episode.